Hey there, friends, and welcome to another Iceland update. Today is Sunday, November 3rd. It is about 8 a.m. Mountain Standard Time. We just switched our clocks last night, which would make it 7 hours ahead in Iceland, 3 p.m. in the afternoon. Thanks for joining me. I am Geology Professor Shawn Willsey. Today we'll look at some new data. I've got some graphs from Bruce Garner to share with you, but mainly what I'd like to focus on with this update is talking about the probabilities of various scenarios for the next eruption, how this might play out moving forward, looking at the most likely scenarios, and then also touching on briefly some of the less likely scenarios as well. I thought, though, what might be fun first, if you'd indulge me for a second here, it struck me that November 3rd was an important date because this is the date last year when I did my very first Iceland video, and that's how maybe a lot of you actually found me and found the channel. And so here's part of that video. Kind of funny right now. You're seeing two of me on the screen there, me today and me a year ago. And it was kind of fun for me to look at this update from November 3rd, 2023, and all the earthquakes we were seeing around Grindavik, just to the north of it, and just me speculating at that time with this 17-minute video on what might take place. And it was interesting to look furthermore into just how much attention I've been giving Iceland over the past year. Just, there's 153 videos on Iceland. Many of them are updates like this one we're doing now, but a lot of them are field-based videos too from my visits there. But pretty incredible to see how much we've learned together about Iceland's volcanoes through this eruptive period and just looking at the landscape itself. So just a little bit of perspective there was kind of neat for me to look at that. And so if you want to check out some of those older ones, those are, of course, available for you on YouTube. But let's start with, before we get into the data, which we usually do with these updates, I want to start with just different possible scenarios and maybe starting back a little bit further, really starting back a year ago when we had this intrusion of magma. We had this magma that had been stored and accumulating in this area near the power plant and the Blue Lagoon. Let's go ahead and put those on here just for fun. There's the power plant and the Blue Lagoon. So we have this magma storage zone over here. And then if you'll remember on November 10th, 2023, this all reached a head when we had an intense swarm of earthquakes. Of course, we had earthquakes leading up to it, but they really reached their max on November 10th, and that was when some of that magma had moved and formed a dike, a vertically oriented, for the most part, region of magma. So it was being stored in mostly horizontal sills underneath the power plant area, but then it found a weak spot in the rocks, propagated to the east a few kilometers, and then formed this dike. And at that point, we all thought, as I did, that an eruption was going to happen at any moment. The town was, of course, evacuated, and it ended up taking another month or so before we actually had that eruption come to fruition. But this dike still exists, and this dike has still been controlling the location of these eruptions that we've seen over the past year. So remember, sills, these horizontal tabular bodies of magma, they're mainly storage zones, and then these dikes, which are vertically or near vertically oriented, those are transport mechanisms. Those are the conduits that we transport magma up to the surface. I have a diagram I'll share with you here in a little bit as well that I put together. So remember, this is where we were. November 10th, we had intruded this dike. Okay, and that since that time we've seen eruptions come. So if we just kind of add the eruptions that have taken place, we had the December 18th eruption, which was located here, and you can see the lava field associated with that. And then we had the January 14th eruption, which was a bit of a curveball because it was further south, a little bit off axis of the dike, perhaps. Although I'm not going to quibble too much with that and the location of this. It's close. It may not be perfect. Then we had the February 8th eruption shown here in red, back similar to the December eruption site and just to the east of the Blue Lagoon and Svartsengi. This one, of course, you'll remember was the one that took out part of the hot water pipeline that was so important to many people on the Reykjanes Peninsula. Then we had the March eruption shown here in blue. This one was notable because it was a fairly large volume and it also sent lava down. I guess we can add the berms in here too since we're getting fancy here. We got lava down along near the coast, within a kilometer of the coast. Lava was approaching the not the just the roadway, but the coastline as well. So there was our March eruption. Then in May, now it's getting a little messy here, but you can see the May eruption here, May 29th. Similar scenario where lava was, wrapping around, in this case on the west side of Grindavik, following the berms here, and came again quite close to the coastline. So there's our May eruption, and then our most recent one, which was the August 22nd eruption, which again was a bit of a curveball anomaly because even though it ripped open the same fissure region, it propagated further to the northeast than what we've seen before. And so we had lava spilling out into ground that we had not seen previously with some of the other eruptions. So given what we've experienced so far, and given how this system seems, what we know about this system, and of course we don't know everything, here's sort of my 2 cents on the whole thing. So let's start with the lowest probability scenarios, low likelihood, and then we'll work our way towards what I think is the most high probability based on the data, right? Based on what we've seen this volcano do in terms of eruptive volumes, in terms of location, in terms of the permeability architecture, the plumbing system that exists in this magma storage zone in the subsurface. So the least likely event would be, but the most hopeful. This is the one, if we're looking at it from a risk aversion kind of standpoint, it would be that the magma influx coming in from the deeper source, filling this magma body, supplying this dike system with magma, if that just ends, if the magma stops intruding into this region, I mean, I'd give that very low probability because it's been doing it for well over a year. There's no reason to believe that the magma is going to just stop any day now intruding into this area. But that would be a possible scenario, right? The magma stops intruding, therefore the magma that's in the subsurface in storage would just continue to cool and crystallize over some period of time. Another low likelihood event would be that the magma finds a new path, that it totally disregards this conduit, this pathway it's established to the surface, and starts coming out some other location, like maybe over here along the older Eldvorp system, which I know some Icelandic geologists have constantly been promoting this as eventually where this eruption is going to go. And it may. That's definitely a possibility. But again, I would put this as a very low probability event based on what we know right now. Could it get there eventually, 5 years, 10 years, decades from now? Sure. Could it, get there in a week or two? I suppose so, but we'd expect to see, we'd have to establish a new pathway over to this site, which would involve intense earthquake activity. So we'd have to break the rock in order to create the pathway over to there. So again, a very low likelihood, low probability scenario having something happen over there. Another low probability scenario would be magma bypassing these pathways that it's already established between, let's say, Hagafelt and up here north of Stora Stogafelt, and erupting at the south end of the system. So anywhere from, Grindavik down towards the ocean. If this were to be the site of the next vent, the next eruption, it's possible, definitely within the realm of possibility. But again, it's something I'd consider a low probability or low likelihood scenario. We'd again also need to establish those pathways, which would involve significant seismic activity in the days or weeks prior to that eruptive event. So again, possible, okay, definitely, but low likelihood based on what we know at this point in time. Now, if we move to more, I guess, moderate likelihood, so if we're increasing the probability, I suppose the next possible scenario might be an eruptive event up here at the north end. We saw August 22nd here. It opened up a long fissure, but it primarily was erupting out of this north vent, this series of spatter cones here. And the likelihood of something going further past this, so let's open up more fissures and elongate this vent to the northeast, I think that's more of a medium probability, a medium likelihood. Again, I don't want to put percentages on these, so I kind of went with these. I couched this in terms of very low, low, medium, and more high. So this would be another possibility is we get vents opening up northeast of the August event. We already know that the fissure was lengthened a little bit. The dike may have been lengthened a little bit too, because this is a little bit beyond where we thought the northeast tip or termination of the dike was. So we could get more eruptive activity in this next event further to the northeast, and that's of course concerned because enough lava out into this area and further north brings it down towards the town of Vogar and also along the highway here that goes between Reykjavik and the Keflavik airport. So there's a more medium, I suppose, probability event. And then I think what's the most likely scenario, with the highest probability, is that we have another eruption that fits somewhere between these events. And let's just maybe take off a couple of them here. Let me get rid of some of this mess. And something between, let's do this one here, the January vent and this August vent. Somewhere in this area here, just east of the power plant and Blue Lagoon, is the most likely scenario. These pathways are established. The magma has already shown that it can move through there and has moved through there several times. So with each eruption, we've actually seen it reoccupy many of those same channels, not with every single one, but with many of them. And so I think this is the most likely event here. Now I bring this all up because there was a recent video on a real popular YouTube channel that projected that the next event was going to produce a very lengthy fissure based on these estimates and projections of the volume of magma in the system, and that would open up a fissure that would extend well to the south beyond the defensive berm here, and then ultimately produce eruptions within the Grindavik area. Now, the channel in the video did say it was, low likelihood, but the point is that they went with what I consider a low probability event and chose to kind of run that. And I don't know if that's just trying to get views or whatnot, but I think it's a bit irresponsible and perhaps sensationalized to promote what I consider to be a low probability event, although possible, and put that out on a popular YouTube channel and promote that as something that people are going to watch and assume that maybe that's the way it's going to go. Maybe that's the more higher probability or definitive outcome for this event. I don't think it's helpful to the Icelandic people who are so reliant on tourism. It's certainly not helpful to Grindavik, which just opened up. And it's a high impact, low probability event that was promoted by that video, which I don't agree with, because I think the most likely situation is something up here. And all that being said, I mean, the Icelandic people, the community, the government, they fully know that an eruption could take place right in that town or in the ocean, and that would be the end of the town. Totally. They prepared as such. They've built these defensive berms. A lot of the homeowners' homes have been bought out here in Grindavik. Many people have sold their homes. They've set up, financial compensation for these people. There's been lots of mitigation measures put in place to deal with that possible eventuality. So they've prepared for this. Ultimately, they know this can happen, and they put those mitigation measures in place. But I think the more likely event here, again, is that we get something similar to what we've seen with some of these last 6 eruptions. This is the zone where the pathways have been established, the magma conduits are in place, and we're more likely to get something here than something beyond this region, down into here or over here, or even further up here. Could happen, well within the realm of possibility, but I think it's a lower probability. So hopefully that makes sense. And let me just show you so what I've done here is I've drawn a cross section, but instead of other cross sections like I've drawn in the past, where we go across the area this way, so I show the storage zone, and we draw kind of an east-west cross section, and then that magma being transported over to the dike. What I'd like to present to you here with this cross section is a cross section along the dike. So if we were basically facing, if you were actually looking this way at the dike with the northeast side on your left and the southwest side on your right, what would that look like in the subsurface? And this is very cartoonish and such, but I hope it illustrates the point I've been trying to make here. And so here's my simple little silly cross section and the idea. So northeast to southwest, here's the ocean. Here's Grindavik. I did give it some scale in terms of the horizontal component, but there is no real scale here vertically. So this is very much a cartoon sketch. And what we have here is the sites of the main spatter cones for each eruption that's taken place. So starting with the December one here, the January one had really two vents. It was that little one that destroyed the homes closer to Grindavik, and then the main area here. The February eruption, March, and then May, those were very close to each other, and then August over here. Realize, of course, that these eruptions began as fissures, so they would have been not just a point on the cross section, but an expanse of the cross section. But I chose just to show it with a point rather than the actual linear length that those eruptions began as. They did, all of them eventually dwindle down to a point source or a main vent, and that's what I've shown here. But the idea here is looking into the subsurface is these pathways are established, right? This is a magma dike. This is a tabular feature that's oriented more or less vertically, and the magma has found pathways and established pathways for it to erupt repetitively along this over the last year. Now there may be, a little. I just, hypothesize maybe there's some small little arrested dikes underneath this southwestern section of the dike here. We don't know that for sure. If there are any, we don't know how long they are, how close to the surface they reach. We don't really know the depth from the ground down to the dike in this area over here at the southwest end. But the point is that we're much more likely to see an eruption along this segment of the dike, or even maybe further to the north. I mean, I drew a kind of an abrupt barrier here, but we don't know exactly what that looks like as well. Maybe it continues in the subsurface a little bit this way. We're more likely to see something in this region than we are to see something further to the southwest. It is possible, and if there's more magma in storage, higher pressurization, the critical component then becomes where's the pressure being exerted and what's the most likely section to break? Is it going to be breaking through this slightly cooled magma that's in this zone here, or is it breaking through this fresh, unbroken rock down here along the coastline? So just a little graphic here to maybe illustrate the point I was trying to get at there, and hopefully that makes sense. The video that we've been talking about here is run by a geologist, and I think that person does great work most of the time. But this one video did just strike me personally as a little bit, going with the lowest probability or a very low probability high impact event. The eruption in the town itself. And out to and into the ocean. Now we could get lava into the ocean, and we can get lava into the ocean in several different ways. It could be an eruption further to the north that brings that down across the road, as we've been discussing, and into the ocean here on the north side of the Reykjanes Peninsula. Or it could be an eruption like we've seen with some of these prior events, where it actually flows down, might go around the berms, assuming it's on the north side of the berms, and then takes it down to the ocean over here. So those are still possibilities, but I think the most likely scenario is an eruption here. There's still quite a bit of real estate for lava to accumulate in here. So I still think the highest probability is not in town and not to the ocean, but we'll just kind of have to wait and see. The real critical thing is where this thing actually opens up, where the vent opens, where the fissure opens up, and then where the primary vent and most of the lava is actually extruded. So hopefully that's helpful there to some degree. And so let's go on and look at the data a little bit here to kind of round this out, and then we'll look at Bruce Garner's analyses and a graph he just sent me today. One thing that's kind of alarming here, if you look at the bottom of the VAFRI site that we use to show real-time earthquakes, it says this service will end soon. You can find information on recent earthquakes at, and they refer you to the Met Office. So if that's true, and I guess it is, that will be pretty sad that we won't be able to use this real-time seismic data anymore. So hopefully, maybe some other entity will step up and supply that um, to us. That would be helpful. But you can see, in terms of earthquakes, last 24 hours, looks like there's just 3 very small quakes along that dike trend, that northeast-southwest trend there. Even if we look at the past week or so, here north of Grindavik, this goes from August 27th to November 3rd. You can see just maybe 15 or so earthquakes in this area, and all very small magnitude, pretty small earthquakes. Most likely, yeah, less than 1. That's a 0.9 right there. So small, scattered, but look, they're mostly occurring along this region of focus that I think is the most likely area. If we started seeing this pattern down under Grindavik or over here near Eldvarp or way up here to the northeast, and we might, that's still a possibility, that would bear watching and scrutinizing and kind of focusing on. But right now we're seeing it in the same place we've seen it over the past year, more or less. Looking at the GPS data, just similar trends to what we've been seeing with the continued uplift of the GPS stations. And it looks like it might be flattening out a little bit here the last day or two, like a little less steep slope, possible change in slope there. But again, day to day, you can't really look at that. So of course, we're looking to see what happens once these points get beyond this threshold here that we had prior to the August 22nd eruption. Once we start seeing these getting to that level and beyond, that's when we're really going to be scrutinizing and focusing on the data a little bit more diligently. Right now, I feel like, at least I've been, kind of popping in and out every couple of days just to see what the data looks like. Once we get to this threshold here, which might take another few weeks into mid to late November, then it might be, for me at least, more of a daily vigil to kind of keep looking at this information. The interferograms are also showing similar uplift data that we've been talking about. So here's the latest Terasar data from the 15th of October to the 26th of October. And again, you can see the bullseye area, the region of uplift right here, just near the power plant and the Blue Lagoon and north of Grindavik. So there's the data there. And then finally, to wrap up here, this update, I did get an email from Bruce Garner. Let me pull that up real quick on my other screen. Yeah, he says, it's been a while since, and thank you, Bruce, for sending this and sharing this with us. It's been a while since I sent an update, and then he'll do it again in a week or so. He says the dates haven't changed much, so his projection of when this thing's going to potentially erupt is pretty much the same. Let me get my little face there out of the way for you. Whoops, now I got to open that back up. Here we go. Yeah, the 3 points reached the same height around last time, 22nd to 24th of November. And in terms of the statistical increase, my forecast predicts a date between Christmas and New Year's is what he's saying. So if you look at this, and we've talked through these before, but the 2 red lines here at the top is his window. He has 2 sort of projected slopes to the data, the uplift data. So that's these 2 pink lines. And then plotting those against time or dates here, that gives him a window of somewhere between about Christmas to New Year's as the most probable or likely, or his projection, I suppose, of when the next eruption might take place. And what he does here is he takes the, you can see that each little spike here, the amount that it increases over the last one, he kind of measures the increased elevation of this specific GPS station, but I think he looks at some others as well, and then plots like what that percentage increase is, applies the dates to it to figure out more or less when the projected window might be for the next eruptive event. And you can see, like here, he was pretty much spot on. On the last one, he was projecting it out a little bit further than it was, but it's pretty close. And so we've appreciated Bruce's analyses over time, and it's a fun way for us to kind of just look forward and get a little better handle on when this might take place. But here we are, beginning of November, and just projecting this same, the data goes up and down, zigzags a little bit, but taking sort of a a linear regression or line of best fit to that, and then extrapolating that out, that gives us sort of a projected window of, yeah, Christmas to New Year's, which would not be ideal for me because we'll be traveling and such. But I'll have my portable monitor and some other things with me that I can give you some analyses and updates no matter what. Let's see, he's supplied a couple other bits of information for us here. I think those were just the same things, just with different uh, GPS stations. So three different sets of graphs with three GPS stations, but all which kind of yield the same window of time. Then there's this one here. This one says, the other item I think is interesting. This is just reading off his email now, is magma accumulation area at different GPS stations. So these four-letter abbreviations are the different GPS stations. Grindavik is down here, of course. Of course, the main area of magma intrusion sort of centered right here, just south of the power plant. Um, this is the drop in height from August 22nd to August 28th. So remember, August 22nd was when this last eruption took place, right? So we've got the area inflated, and then we get the eruption occurring. And so we actually have the area. Let me actually pull myself up a little bigger here. There we go, because I might be talking with my hands. So the area is inflated. The magma is primed. We get the eruption, and so there's actually a downdrop. There's a response to the magma actually now moving up through the conduits out to the surface through the vent, and so we get some deflation at the surface. And so he has that modeled as well. So you can see that the size of the green circle is sort of proportional to how much subsidence or deflation, if you will, occurred at each one of these GPS stations. And what's nice here is this is really showing us pretty well, um, or crudely, I suppose, the geometry and extent of the magma storage zone. So these areas that are inflating highly are right above the area where the magma is accumulating in the subsurface. And then when we see those respond the opposite way with deflation or subsidence, it's responding to that magma withdrawing from the subsurface and coming out to the surface. So then his next one here is a plot of since August 28th, the increase in elevation. So again, you can sort of get a feel for how much or what area is most directly impacted by the magma that's accumulating in the subsurface. So it's really this area right around the power plant, kind of stretching down to this area just west or northwest of Grindavik, and a little bit out towards the Eldrup area as well. This is the area where the main magma storage seems to be taking place, because that's where most of the inflation is occurring as well. And then finally, he has just a plot of earthquakes. This is stretching back to March. So this is total number of earthquakes in the area. And you can see those really ramping up here last spring in April. There was a quick little lull here, but overall a definite upward trend in earthquakes, culminating in the day of the eruption there, or the day before the eruption, I suppose, as well, on May 29th. Everything drops down. The eruption is taking place, so there's little rock breaking, and so we see very few earthquakes. That eruption eventually kind of dwindles down and ends, and then things start ramping back up again as magma accumulates. The system becomes pressurized, and then we get another spike here right around August, what was it, August 22nd, 23rd, when we had the eruption take place here. A little bit more and more protracted here because we did have that initial fissure in August open up further to the north over time. It actually opened up near where all the other fissures were, but over time it propagated and produced a lot of earthquake and seismic activity further to the northeast as it lengthened the fissure and then settled into that one cinder or a spatter cone up there. And so we see a little bit longer time period with heavy earthquake activity. But nonetheless, it drops back down. And now we're just kind of in this lull here as we roll into, oh, I'm probably covering this, aren't I? Sorry. Here we go. There, I'm shrunk down now. So yeah, here's our August event and eruption with earthquake activity, but then everything drops back down, and so things are quite quiet. So the real question will be, it should be soon, I would guess. I would guess in the next maybe month, well, a couple weeks to month for sure, we should start to see this uptick in earthquake activity, and it should become more pronounced and more exaggerated, I suppose, as we get closer and closer. Once the system's full and the rocks are starting to break as that magma is propagating into these pathways and the system becomes pressurized, then we're going to see this uptick in earthquakes. So I think it's the calm before the storm, if you will, in terms of earthquakes. I'd put this little section we're at here might be like something like here. What July, mid-July was, and then you can see as we got into late July and into August, things really started to ramp up. So we'll have to see if that kind of trend continues as we move forward. So that's all I have for you for today. Hopefully this was helpful, just to look at kind of where we've been and just different scenarios related to this next event, which it seems to be kind of percolating and building up towards some sort of event here, probably in December, possibly in 2025 in January. So we'll just have to see. So thanks again for your time. I'll continue to update you as best I can, and appreciate your support of the channel, and be well. Take care.